In a previous video, I showed how we can think geometrically about complex numbers and what it means to do complex addition, subtraction, and multiplication. So naturally, the next thing to ask is about complex division. We'll look at that in this video, but first we need to take a quick detour into complex conjugates. So what is a conjugate then? If we take the complex number in the form z equals a plus bi, then we can define its conjugate as a minus bi. We normally denote this conjugate as z star. Now let's recall the complex plane. If we put a plus bi on here and a minus bi, it should be fairly obvious that z star is a reflection of z along the real axis. Z star is almost like z. They have the same magnitude and they have the same argument, but they're negatives of each other. It's also worth mentioning that, although I generally show complex numbers in the top left quadrant just for simplicity, the same applies in all of the other quadrants. That's all well and good, but why is this useful? Well, let's look at the problem w equals z1 divided by z2, where all are complex numbers. We can solve this algebraically, but we run into a bit of a problem. There's an I in the denominator. We can work around this by multiplying both sides by the conjugate of z2. If you remember the difference of two squares, then we can see that this I squared becomes a negative 1, which make the denominator just c squared plus d squared. Okay, so algebra, 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 and we get this closed form solution. But what does that mean geometrically? Now I'm going to describe this in a way that's hopefully still quite interesting and still convincing, if a little hand-wavy. But it might be a good idea for you to see for yourself by proving this algebraically as an exercise. So in that solution, we divided both sides by the complex conjugate of z2. So let's look at that on the complex plane. z1 getting multiplied by z2 star gets transformed by rotating by the argument of z2 star, which is the same as rotating clockwise by the argument of z2. And then its magnitude is multiplied by the magnitude of z2. Similarly, the magnitude of z2 and z2 star are the same, so by multiplying them together, we end up with the magnitude squared. Also, as the arguments are reflections of each other, they will cancel each other out and we will land on the real number line. So we can divide the new numerator by the new denominator simply by scaling it down as it's a real number. In total, to divide z1 by z2, we've rotated it clockwise by the argument of z2 and multiplied it by the magnitude of z2. Then we've divided it by the same magnitude squared, so that cancels out and we're left with this. To divide a complex number, subtract one argument from the other and divide the magnitudes. I think this is actually pretty intuitive as the opposite to multiplication. In that case, we rotate counterclockwise by adding arguments and stretch the magnitudes up. In this case, we subtract the arguments to rotate clockwise and we squash the magnitude down. I hope that's given you more insight and intuition into the mental model of what it means to divide complex numbers, and now you can do all of the basic operations on them. Thanks for watching.